That's where I'm from. Every now and then people ask me, oh, that's hard to see on there, isn't it? But I am from northern Greenland, a place called Kakatasuaq, on the island of Disco, in the middle of Disco Bay. And born in the 60s. I'm old, as the keynote yesterday was saying, we're all getting older. I'm sort of leading the pack here, I think, almost. There might be one or two older in the room, but not many. This is me. Still me. Family, my parents on the dog sled. It's a pretty crazy place to grow up. This was the house. That's the view in the summertime of the house. And the backyard and the front yard, I guess. Me hacking. More hacking. Getting older. Still living in northern Greenland. Very, very crazy place. So this is before the 25 years starts, but this is sort of the getting there. Then in the 80s, started hacking on actual computers, although not sure you can call this a real computer. It had 1024 bytes of memory, 1K, native. That big box on the back was a 16K memory expansion. Crazy, completely crazy. Compared to what my son has today to play with and hack on, it's nuts. VIC-20 modems, Z modem. I mean, this was me growing up. This was my internet, if you will. There was nothing. 80s or 90s, we started getting closer with Gopher. When I was in university, I used Gopher, reading research papers. At the bottom of the research papers, you could scroll down with cursor keys and click on links to other research papers. That was as close to the web as I ever saw in university. After I graduated university, in October 1994, Mosaic was released. First graphical web browser. And here the 25-year counter starts for me. This changed everything, right? And not just for me, for everybody. And it wasn't just me that could see that this would change things. Everybody around at the time playing with this stuff and having had UDP addresses and playing with Usenet and bulletin boards, it was very easy to see that this was going to change the world. So I started hacking on this stuff right away. The web looked like this, CGI bins written in C. Not a pretty site, and not something you'd want to maintain. Having HTML inside your C programs was not a nice thing to have. Lots of people starting using CGI PM, Perl module for writing CGI programs. And I didn't like this any better. Still programming your HTML in some other language, which to me made it impossible to separate the business logic from the templating and the look and feel, the layout of the page. And I wanted those two separate, which people, especially sort of the non-PHP types, tend to chuckle at because PHP is quite well known for mushing it all together. That wasn't the original intent. My intent was to have very, very simple templating. So that's the same example written in Perl and in C here would look like this in the PHP templating system. Right? It looks like HTML with just a few tags here and there where you need the dynamic content from the form submit. My grand scheme was to write a C API for the web. So abstract away all the web-specific things that you needed to know to get your business logic up online. And the idea was that you would create these template tags. You would add your tags to the templating system by writing small C functions. So here's an example of like a cosine function that you might want to add. It was stack-based. So the tag would pass, the templating system would read this, find this tag, and say, hey, okay, this is tag name cos. There's an argument input. It would pop or push the input argument onto the stack, In the C code, we pop off any arguments from the stack, call whatever function, and then push the result back onto the stack. And that's how it would work. And you wouldn't need to know anything about how to parse cookies or HTTP requests, get method variables, post variables. All that stuff was taken care of for you. All you had to do was write sort of the core piece of your business logic in C, and then expose that business logic to your templating system. Much like you do in things like Smarty and things where you assign values to variables and expose that to your templates, except you're assigning it from C. And this is how I liked to solve the web problem back then. And I did figure other people might like to solve it this way too. I was completely wrong. Nobody wanted to write C code. And it was a bit distressing to me at the time, actually. I was trying to convince people. People would email me and they would say, this PHP thing is cool. You have all these tags built in, and I included a whole bunch of demo applications and tags and things. And they would say, well, we also need a tag that does this. We can't figure out how to do this. And I would show them, this is so easy. This is the C code to do that. And they would say, thank you. And then now we need this one. We can't figure out how to do this one. And I would do it, and they would trick me into building their site, basically. And it just kept going and going. And then people started asking for more and more logic in the templating system. So recursion, things like that, that I didn't really see any need for in the templating system. And I wasn't all that good at writing a language parser. I mean, the templating system was pretty simple. It was just a state machine. You were either inside the template tag or you weren't. And it was very, very simple in the beginning. You couldn't do math. You couldn't do anything in the template system. But people started asking for stuff like that, like just math itself is really, really hard if you're programming it, right? Because I was parsing it. I wasn't using Yak or Lex or anything. I was just parsing it left to right. And you get 1 + 2 × 3. You can't do that left to right. You get the wrong answer, right? You have to do the multiplication before the addition, and the whole thing just kind of gets really complicated really, really quickly when you're just trying to build a state machine in your head that parses an entire language. But it was very obvious that people preferred just working in the templating system. And I shifted the focus completely away from necessarily, I mean, I got the language working. I read a book on Yak and Lex and kind of figured out how to build a somewhat usable parser where I could offload like the math handling. Yak and Lex could take care of all that for me for the most part. So I got a parser that kind of sort of worked okay. And then I worked a lot on the ecosystem in the early days, making sure that all the different pieces could talk to each other. Because really what you need a robust system where you can talk to all the different things that you need to talk to. You don't necessarily need a beautiful language to program in. You can have the best language in the world, and if it doesn't talk to your Oracle database where all your data is, there's absolutely no point, right? And that's really what I focused on. I focused on making sure that the 4 pieces that are critical to a web application would work well together. So an operating system, a web server, scripting language, and some kind of back-end data store, a shared data store. And it really wasn't an accident that LAMP came around. And it wasn't just me. I mean, I got the ball rolling, but there were lots of people that helped out in getting the whole ecosystem running well. And some of the things over the years, like initially mod PHP was the big one. Embedding PHP into Apache was huge because other languages, especially back then, were faster and better, but they all ran as CGIs. Perl was way faster than early PHP, but not once you embed PHP into Apache. By the time you fork and exec a Perl process and wait for the interpreter to fire up on every single request, PHP was already done. The fact that by the time Perl got started, it was really fast didn't help them because their overhead was so high being CGI. It took them a couple of years, but a mod Perl eventually came around. They figured out, hey, we need to do this too. We need to embed Perl into Apache. And they completely messed it up because they made it way too powerful. I only hooked the content generation hook in Apache, which is when Apache has figured out where's the document root and where's the script and everything, then it would call PHP and say, okay, for this particular file, the handler is PHP, run PHP, and send the content back. With mod Perl, you could hook all the different request hooks in Apache, including the path translation hook, which is the hook that says, for this particular request, this is the document root. That meant that if you are on the virtual host on an Apache server and you had mod Perl access, you could steal the request from every other virtual host if you wanted to, simply by hooking the path translate hook and pointing everything to your document root. And that meant that ISPs could not offer mod Perl as a shared virtual host alongside other clients in a single Apache instance. So if you came to an ISP and said, I would like mod Perl, they would say, okay, that'll be $600 a month, because back then we also didn't have VMs, containers, or anything like that. So you had to have a separate physical bare metal box for mod Perl. Whereas on PHP, you could put 3,000 customers on one machine versus one mod Perl customer. So it died. ISPs would offer it, but nobody would want to pay 100 times more for Perl versus PHP. I also pushed really hard for a long time in the beginning for the whole concept of a shared nothing, perfect sandbox model, where we fire everything up and tear everything down after a request. No state is stored in PHP server side. If there is any sort of state on a per machine basis, it's something that you did as application developers. And also multi-threading. I've always been firmly against any sort of multi-threading because it just gets too complicated. We as humans are not smart enough to write complex multi-thread safe code. And when you link in dozens and dozens and dozens of third-party libraries and expect them all to be thread safe, there's just no way. If the scope is limited enough, you can write thread safe code. But for something like a general purpose glue language like PHP, there's just absolutely no way you can get that right. And also, if you have multiple threads, if one screws up, which it will take down all the other concurrent threads. Even today, 25 years later, at Etsy, where I work, we run PHP, and every now and then there's a seg fault. It's rare, maybe 1 or 2 a week, and I have no idea why they happen, but I don't really care. It's like one every 3 billion requests will cause a seg fault, and Apache just says, okay, we'll start another child, who cares? We move on. That makes it robust. If we're in a multi-threaded server, and one child dies or causes any sort of memory corruption, that entire group of concurrent connections are going to die as well, which is not a good thing. And HHVM stepped into that one as well, because they do multi-threaded concurrent request model. Other things I worked on in the sort of the ecosystem bucket was the SQL limit clause, because I was using a database called MSQL. This was pre-MySQL, 1990, late 94, early 95 or so. I was using MiniSQL. Super smart guy named David Hughes in Australia had written this tiny little database that was perfect for the web. Its SQL was quite limited. It didn't have, I don't think it even had joins back in the early days, but just as a very simple data store that was perfect for simple web SQL queries, it was awesome. But it had no way of limiting the number of results you got back from a query. So if you made the fatal mistake of doing a select star on a table that had a couple 100,000 rows in it, and because we didn't have any sort of 10 gig network cards back then, you were waiting for a while for that entire result set to come across. And if you only needed the first one, it really sucked. Waiting for 400,000 rows and then just showing the first one, right? So it was super obvious to add some kind of limiter to these SQL queries. So I arbitrarily named it limit and patched it in, got it accepted upstream in the thing. And that has caused limit now to propagate to many, many databases, which I find kind of interesting. And it's not standard at all. There is an ANSI SQL standard. There's no sign of limit in the standard still. Also on the ISP side, like maximum execution time, memory limit, and safe mode helped ISPs feel a little bit better about offering PHP, because they could say, well, even if you write a while true PHP script, that kind of hurts the server, but because there's maximum execution time, which is CPU time based, after that many CPU seconds, it'll just get killed off. So it was somewhat okay for an ISP to put thousands of PHP users on the same server. Still not ideal, but in the early days of the web, it was very sort of Wild West. You kind of hope for the best with just about everything you were doing. Some of the things over the years that people keep asking me about, like case insensitive function names. It doesn't make a whole lot of sense today. But for all of these decisions, you have to take the context in mind. This is from 25 years ago, this one. When the web first started, there was a huge religious battle on whether HTML tags should be uppercase, lowercase, or even mixed case. Because my templating system wanted to fit in this world, and I didn't want to take sides. I wanted everybody, no matter what their religion was, to be able to use PHP templates. These tags, which were essentially just function names in the early days, there was no point making them case sensitive, because then people would complain that they couldn't fit into their style that they were used to in their HTML. And that has just stuck. Now, in HTML, when everybody did finally sort of get to lowercase, I probably should have switched it. But I remember thinking about doing it, 97, maybe 96. And I remember thinking, this will affect hundreds of sites. And I thought, man, I can't inconvenience hundreds of sites. Looking back now, it's like I should have inconvenienced a couple of hundred sites at the time. But I had no idea. I had absolutely no idea. I figured at every point along the way, I figured there was about 6 months of life left in PHP, because that's about the amount of time I thought it would take for somebody to write something real that could replace it. And that also would work for me. And I kept waiting for something to come along that I could use that would work for me. And nothing did. Idiots came out with stuff like Cold Fusion and other things, and I looked at it and go, what the hell? This isn't how you solve the web problem. And Cold Fusion became popular even. Like, wow, this is just a weird world we're in. I guess I'm stuck with this. Naming inconsistencies. There aren't actually any. The naming in PHP is perfectly consistent. Just not the way you expect. Dollar signs. People have complained a bit. I even have people saying, why dollar? This is very American-centric. Come on. Globals. This is actually one of the better decisions, I think. Very few languages do it. I'm not sure any languages actually handle globals the way PHP does. This came out of a huge debugging debacle I had pre-PHP. I was at a company called Nortel in Toronto as a co-op student. And I was given the task of tracking down a really complicated bug that would take down this automatic call distribution system. Every couple of months, this was a system that would distribute calls geographically across Canada for the main customers, Air Canada. So if people called in after hours on the East Coast, the calls would get routed to support people manning the phones on the West Coast because it was 3 hours earlier out there. So they had these queues. You sit there on hold waiting in these call queues. And every couple of months, the system would just drop every call out of the queue, which Air Canada was quite unhappy about, understandably. But nobody could figure out why every couple of months this would happen. They tried finding it for years, and they didn't see it. So that was my task as a co-op student, and it was kind of a joke. They was like, fix this, like, good luck. They didn't think I would get anywhere. They figured I would learn the system from trying to track it down. But anyway, I printed out the source code on the huge wide.matrix pages we had back then, taped it to the walls of all the hallways in Northern Telecom there. And after hours, I'd always put it on the floor, and I would have these highlighters, different colored highlighters, and I'd be crawling around on the floor and on the walls. I had a chair I could stand on to reach the higher things, and I would just sort of manually debug everything and try to track down the flow of this thing. And it was nasty. And in the end, after 3.5 months, it turned out to be a global variable collision. 2 separate pieces of the code, completely unrelated, had the same name for a variable, and it was global. Changed in one place at exactly the wrong time would cause this other code to go crazy. And the C compiler at the time had no way of informing us that that was happening, and it was just crazy. And when I started adding variables and scope to PHP, I remembered that. There was no way that in PHP I'm going to be spending 3.5 months tracking down something like this. That's bullshit. So in PHP, if you're going to step on a global, you have to damn well declare the fact inside a method or a function that you're going to step on a global. So you have the $globals array with huge capital letters. This is a global, or you have to declare at the top of the function global, right? So you can't accidentally step on a global in PHP. It's changing a little bit now with the auto capturing of the arrow functions that's coming, which worries me a little bit. The first time a bug appears because of auto capturing and arrow functions, I'm going to go kick Nikita. Register globals. Without register globals, we wouldn't be here, honestly. Register globals enabled users who had no idea how the web worked to build dynamic pages, to put up an HTML form, name, age, address as the field names, and then add tags that just said echo name or if age is greater than 19 without thinking about anything. The fact that field names became variable names in PHP was the killer feature in the early days of the web, where people didn't even have to think about how it worked, it just worked. Also context. There was no JavaScript. You couldn't do cross-site scripting. You couldn't do any of the things that in later years you could do with register globals turned on. Magic quotes. Magic quotes was me being lazy. I admit that one. This was not a good solution, but it took me a while to discover that I should probably be careful about letting user data into SQL queries. I'd already written this big system for the University of Toronto, and I had dozens of PHP files. I was like, oh man, I have to go through and then filter all my SQL stuff and all my input data. Forget it, I'll just do it once, and I'll turn on a flag, turn on magic quotes, and have PHP do it for me, because I was too lazy to edit my files. So yeah, I don't have a good excuse for that one other than laziness. But it also comes back to my 6-month thing. I always thought I was 6 months away from the end of life of PHP. Right? This was a tool primarily for me that other people started using, but whatever. I mean, once that new thing came along that fixes all the problems, we would all switch to that. I could never have imagined I'd still be talking about this thing 25 years later. So on the consistency thing, I'm saying that, hey, it's perfectly consistent. Do you realize that every single array function is needle haystack, and every single string function is haystack needle? Perfect consistency, right? So the consistency in PHP is vertical, not horizontal, because of the way it grew organically, right? So different people wrote the various extensions. So when you're talking to the Oracle, database using OCI 8. The functions that talk to Oracle from PHP are almost a one-to-one mapping of the underlying C library functions or the API functions provided by Oracle. Same with the MySQL functions and the other database functions. And all across PHP, even the string functions are direct one-to-one mapping of libc functions, right? So the argument order and the names come from the underlying libraries that we're wrapping, where PHP is a very thin wrapper, basically just exposing these C libraries directly to you. Getting horizontal consistency across a diverse set of underlying libraries would have taken a hell of a lot of planning and organizing and sort of predicting the future. The web was moving so fast, there's just no way that that would happen. We needed a tool right here and now. The web was growing like that. And if I had sat around worrying about horizontal consistency, we also wouldn't be here today. All right. A little bit more current stuff, 7.3. Hopefully everyone in this room have at least looked at 7.3. Hopefully you're in the middle of migrating everything to 7.3. Is anyone in here still running PHP 5? You're killing me. Man, I was expecting maybe 1 or 2 hands to go up, but the whole back of the room lit up, okay? Anyway, so in 7.3, also in 7.0 for you folks in 7.1 and 7.2, there are some nice, cool new features, but in 7.3, we made hairdocs look a little nicer because the ending tag doesn't have to be in the left column. So whatever that's indented by is the same indentation you'll see in the output. So if it's in 4 spaces, then 4 spaces will be removed from the content. Continue and switch. A continue is probably wrong if it's a continue inside a switch that's inside a loop. People might expect that that continue will continue the loop. It doesn't. It acts just like a break when you do a continue in the switch. So PHP 7.3 has a warning that says this should probably be a continue to. It either should be a break or a continue to. So if you see these, and you did mean a break here, then just change it to a damn break. List references, both the long syntax and the short syntax now support references. Trailing comma allowed in function calls now. We had kind of forgotten that. In 7.2, we added trailing comma support to most things, but we didn't add it to this one. There's also a new monotonic timer function. If you're doing any sort of timing in your PHP scripts, currently pre-7.3, you're going to be relying probably on microtime to do this timing, which is pretty broken because microtime relies on the system clock. If you have NTPD running, NTPD can speed up, slow down, stop, even make your clock go backwards. Well, actually, I don't think NTPD can make it go backwards, but it can make it stop for a little while. Your system administrator can arbitrarily change the system clock and make it go backwards. So if you're timing something and your end time is before your start time, things get weird, right? And also just the fact that NTPD can slow down the clock a little bit just to sync it with the NTPD time also means that your timing is not going to be right. The monotonic timer function will always click forward 1 second per second. And this is really what you should be using to time things. There's a cool new FPM get status function. So you can write very pretty dashboards, kind of like the Apache scoreboard, where you can see what each request is doing. You know, in Apache, you can do like a status/status and get the scoreboard. You can now write something similar if you're running FPM. It's countable. One of the big changes in PHP 7.2 that makes upgrading really, really difficult sometimes is that count complains if it's called on things that aren't countable. So if it's not an array or not an object that implements the countable interface, it complains. We saw that a lot of people were calling isArray or instance of countable to try to figure out if foo is countable. Now, your code, you really should know what type of variable you might be dealing with here. But that's not really the PHP way. In PHP, you never know what the hell is in a variable. Because you've written code when you have methods that can return 6 different types based on all kinds of different things. And so you don't know. So you have to check, can I actually count this? So there's the new isCountable function in PHP 7.3 that just reduces this boilerplate to something a little less nasty. Also, to avoid the reset usage, like people will call reset to get the first key of an associative array. And that also moves the array pointer, which means that you can't call it on something that doesn't have storage. You've probably tried to do like a reset on a function call that returns an array, and you end up getting an error, right? With array key first and array key last, you can now get the first and last keys very quickly without any side effects. There's a whole bunch of cool DCE and SCCP optimizations in 7.3, which I'll talk about in a bit. Some other changes. The big one here from a sort of a stuff that will break your code is the PCRE2 upgrade. It should be rare. The main difference, well, there are actually quite a few differences between 1 and 2, but in PCRE2, the main one that you will likely hit are invalid character classes. You know how in character class you have sort of in square brackets A-Z, for example, and that means all the letters from A to Z. If you have A dash backslash S, so A to white space, what does that mean? Who knows? And in PCRE1, it says, we don't know what this is, so that dash in the middle must mean a literal. So this is a dash, and white space in PCRE1, which makes some sense, right? Because it's in an invalid character class, so it's not actually going to be a class. It's not going to be a range. In PCRE2, they've said, well, you try to build a range. This is an invalid range. This is an error. And it won't compile the regular expression for you. And you'll see a big warning in your error log, if you ever look at your error log, which I don't think many people do. You'll see a big warning, unable to compile regular expression, and your code will break. The count thing in 7.2 is just noise in the error log. It actually still returns the same value, so it doesn't break your application. This one breaks your application because it won't compile the regex, and that regex will not do anything, right? So when you do the upgrade to 7.3, make sure you scan your error log and your unit test and everything for invalid or errors from PCRE saying it couldn't compile your regular expression. And most of the time, all you have to do is go in and add a backslash in front of that dash to make it a literal. Because that's how it worked before. In PCRE1, it was treated as a literal dash. If you add a backslash to it, it'll be valid in both PCRE1 and PCRE2, and it'll do the same thing. Read the migration document. If you have extensions, read the upgrading internals document that helps you figure out what you need to fix in your extensions. And for the folks still on PHP 5, you have a lot of these to read, right? So there's migration 7.0, 7.1, 7.2, 7.3. If you wait a few more months, you'll have another one to read, 7.4. It gets harder and harder the longer you wait. All right, 7.3, Dmitry in St. Petersburg has been having lots of fun with DCE, escape analysis, and SCCP, sparse conditional constant propagation. Sounds very complicated, but it's actually not complicated at all. It's kind of fun. You can dump opcodes after the optimization pass with a tricky little set of settings like this. Opcache optimization level -1 to turn on all the bits and set it to hex to 20,000. It'll spit out the opcodes after the optimization run. And you will see, for a simple script like this that just has a function, and because of the globals in PHP, this is a local variable, there can be absolutely no side effect from setting a equals 1. And since we don't use $a anywhere and just return 0, this is useless. this assignment serves no purpose whatsoever. In PHP 7.1 and earlier, we still create the opcodes for it. So we have the assign opcode that assigns 1 to $A, and we return 0. 7.2 and 7.3, the optimizer sees this as being redundant and doesn't even generate the opcodes, which means they don't get cached in opcache, and that's really where you're executing from. So essentially, it's just deleting that line of code, and that never gets run, which also means your code runs slightly faster because there's one less opcode to step through. More complicated things. So here, the CV lines is basically just saying where the input arguments are stored. These aren't like executable opcodes. It's just saying these are stored in these 4 places. Then 7.1 will happily concatenate, do the concatenation, S1 and S2, S3 and S4, and then they concatenate the result together here. T6 and T7 get concatenated together. So now we have the final $x. Then we overwrite $x. Well, we write T5 to X, then we overwrite it with 0, and we return X. 7.2 and 7.3 see through all this mess and see that, hey, all this concatenation gets overwritten in the very next line. Plus, X is always 0, so we don't even need X, right? So it replaces all this mess just with a return 0 opcode. No concats, no creating a variable X, nothing. That stuff never happened. You can try to trick it, stuff like this. It figures it out still. So here we're only incrementing A. We're also setting B to that result, but since we don't use it, the B part gets eliminated. In 7.3, it has gotten smarter with array stuff. So in 7.2, it couldn't figure out arrays like this, and also objects. So in 7.3, it looks up one level to see or to test for side effects. So if you instantiate an object like this, if there's no destructor and no constructor, then there's absolutely no side effect possible from instantiating $A here. And even setting a property. There's no setter up here either. So the opcodes just removes everything, and it just returns X. If in that same example we add a destructor, now you can see that it did not remove those opcodes anymore, because now there could possibly be a side effect. Once $A falls out of scope and the destructor is called, there could be a side effect there. Even though in this case the destructor is empty, it doesn't actually check, because that would be another level to check. It doesn't actually check if the destructor is empty, it just checks if it's there. Also, it's smart about arrays now in 7.3. So here, if you kind of follow this, it doesn't matter if X is true or false. We're only ever returning the first element of the array. So all this stuff gets replaced with just a return 0, because the optimizer sees that no matter what the input is, the output is always 0. So everything in between can go away, since there are no side effects, and you can delete all that code. And you can go kind of crazy, have code like this, right? The optimizer tells us that all this does is echo 1, return 4. And you can try to make your way through it and validate the fact that it will always only echo 1, return 4. That's a lot of opcodes that have been eliminated. So, like I tell and most people, don't talk too much about how much faster your code is under PHP 7.3. Because if it's drastically faster under 7.3, you've written code like this, right? It should be 5%, maybe 10% faster if you stretch it over like 7.1, 7.2. It should not be like 30, 40% faster. If it's 30, 40% faster, then it's the optimizer eliminating all your code, basically deleting your code and saying, you're an idiot. All this code doesn't need to be here, right? So this is the real performance gain you can expect from 7.3, the last bar here, right? So going all the way back to 5.3, this is in requests per second, 154 requests per second for the front page of WordPress 4.9.8, versus 520 today for it. And latency has also been dropping nicely. 140 milliseconds using PHP 5.3 down to 38 now milliseconds on my test box. So the actual absolute numbers don't matter, but the relation does matter, right? Things have gotten faster. Every single version, we get a little bit faster. And memory has shrunk quite a bit. Running on 5.3, we need 140 megs. Today, we need 15 megs to serve up WordPress. Version support, this is where we are. If you're running anything other than PHP 7.2 and 7.3, you're behind and you need to upgrade. If you're still running 7.0, do you realize PHP 7 was released in 2015? On the internet, on the web, that's old. It's old code. PHP 7.0 is no longer supported in any way whatsoever. Not even security fixes are being done. So if you're still there, and for the folks still running PHP 5, it's just irresponsible, honestly, to be running code that old on anything that might be important. I mean, if it's your blog or something, fine, no problem, right? But if it's something that's dealing with customer data or anything that is actually sensitive, you can't be running code that's 10 plus years old. You can't do it. All right, static analysis. One of my side projects that I started and handed off to someone smarter than me, which is sort of my pattern. I start things and I get them going. I get them just to the point where they're useful enough for someone else to continue it, as opposed to completely starting their own thing. Easy to install. Composer require dev fan. Very simple config file. If you have a standard sort of composer set up with a source directory and a vendor directory, you can tell it, this is my source directory and my vendor directory, scan it, but don't report errors for that one. So this is the exclude analysis directory list. So it'll still be part of sort of the map because you need all the dependencies, you need all the types from those because you're calling into them. But you don't want to hear about any errors in other people's code. And then you run vendor bin fan. If you've never done it before, you're going to get hundreds, if not thousands, of errors reported about your code. You can add some filters and say, I don't want to know about this type of error. And there's a whole bunch of different filters available. It checks a ton of things these days. This is just a very small list of things it'll check. As a quick example, if I have a class like this with a function that takes 3 arguments. The first one takes either a string or an integer, called union here. The next one takes an array. And in the native type in PHP, you can just say it's an array. With fan, you can give it a more specific type. You can say this is an integer array. And fan will check that it's never passed something that's not an integer in that array. And then the last one is a shaped array. And that's actually saying this array must have a key named mode with a value that's a string, and a key named max with a value that's an integer. If we get something that doesn't match this definition of the function, fan will complain. So here, these first 3 calls are okay. We have string, integer array, and a shaped array that matches. This time we have an integer, which is fine as well, because this is either string or int. And this one is fine. What did I even change here? No, doesn't matter. Then this one is not fine. The first argument is an array, right? And that's not part of the union, so fan complains saying that the argument 1 is an array, but the function takes integer or string. Another example here. Here the shaped array is missing the mode element, so it complains about that. So these are some of the things that you can expect to see running fan. Another tool, much newer than fan. Fan is 3 years old now, I think, 4 years old maybe. Lower head profiling is a cool new thing that we've worked on at Etsy. A guy named Adam, super smart guy, wrote this thing. It's a little bit like RB Spy. I think there's a PySpy as well. You run it like this. You can attach it to any PHP process whether it be a PHP FPM, whether it is HTTPD with mod PHP, so PHP is running inside HTTPD, it doesn't matter, or just a standalone PHP process. And the sampling frequency by default is 99 milliseconds, I think, if you don't specify it. 99, not 100, because if you set it to exactly 100, there can be some timing issues where you happen to exactly miss something, because things tend to happen in hundreds of milliseconds as opposed to every 99 milliseconds. So by offsetting it slightly, you're more likely to not run into any sort. But you can also change it yourself. In this case, I've set it to a lot of nanoseconds. That's 200 milliseconds. And I'm checking a script that's just sleeping for 1 second. So every 200 milliseconds, I'm asking PHP, what are you doing? 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 And it comes back every time with a little backtrace telling me I'm sleeping and I was called from main, right? Because this runs for 1 second, then we check every 200 milliseconds, we get 5 answers. And then we get a no such process at the end because PHP has stopped. Here's an example of attaching to a PHP FPM process that's currently serving WordPress. And you can see that the what are you doing response is a lot more complicated now. The stack trace is much deeper. You can also get the memory usage from each frame if you pass -m. And here, if anybody wants a project to contribute to, it'd be great to have some support for perf or call grind or some other way of visualizing the memory here. It would be a nice one to add support for. It's on the to-do list, just nobody's gotten to that part yet. We have the numbers. The hard part has been done. We're getting the numbers out every stack frame, but we need to visualize it somehow. For the straight, what are you doing and how much time are you spending in places, we have output. We have a flame graph that you can generate. There are some scripts that come with PHP Spy. One is a stack collapse. The other is flame graph, which is a Perl script of all things, which is kind of cool. And what you get out of this is a flame graph that looks like this. So this is me running running PHP Spy on fan. So if I zoom into some of this, I can see, like here, in analyze and get updated context calls into this other thing, which is a visit statement list, which calls into analyze and get updated context again. And up the tree we can go. We can follow it all the way up. We use this thing at Etsy a ton. We have a Gearman pool of servers that handle Gearman jobs. Some of these are quite long running. We also have servers doing cron jobs. And again, some of these run for quite a while. And sometimes they run a lot longer than we think they should. And it's hard to know what the heck they're doing. Because we try it like on our development servers and it never runs for more than 6 minutes or something. And then in production, this thing has been running for 40 minutes. What's it doing? Right? We can't replicate it. But with PHP Spy, we can hop on the production server, attach to the running process without slowing it down, and see what it's doing. Where is it spending its time? And PHP Spy is magic because you don't have to compile PHP in any sort of special way. You don't have to have debug symbols. You don't have to have anything. You can have a completely stripped, optimized GCC-03 compiled binary, and it'll still give you this output. And it does it by simply looking at the kernel memory. You have to run it as root, which is, I guess, a bit of a problem for some. But it's because it needs to look at the kernel, basically. It knows the offsets for the different versions of PHP. So it knows where the EG globals live, for example, the executor globals live in memory for PHP 7.3. Right? That's a certain offset. And it knows where all these places are. So it's just looking at memory and seeing what's changing. It also has an option to spy on a variable. So you can track. You can set every 99 milliseconds, tell me the value of this variable. And you can track how that's changing over time. So there's a lot of front-end stuff that could be added to this to make it even cooler. Adam has mostly been focusing on the back-end part. He also hates public speaking. So if you want a project where you can have pretty much a guaranteed accepted conference talk for, come contribute to PHP Spy. Add the cool front-end support for some of this stuff and submit the talk. And I guarantee you, it will be accepted because it's really cool, and Adam's not going to mind. He would love someone else to talk about PHP Spy for us. All right. PHP 7.4, coming out later this year. Type properties. Yeah, if you don't care about performance, you can clap. But I mean, hopefully we'll come up with ways of counteracting the performance hit that this is going to take. There is some, obviously. This is also why we're not going to do it for standard variables, because every single time you modify one of these, we have to add a type check. So think of a loop iterator. While $i++, right? This thing, every time through the loop, we're modifying the variable. For properties, that's less of a problem. Presumably, you're not doing while $this II++, right? Hopefully not. People typically don't make iterators a property of their classes, right? So you tend to write less to them, which is why the performance hit on properties isn't as big as it would be typing regular variables. Arrow functions, recently accepted. These two are similar, or identical. So you can see Y is auto-captured here from the outer scope. You can have nested arrow functions. You can also put types in if you wanted to. You can add a type here. You can put colon return type as well on it. Pretty simple. Serialization has always been an issue in PHP. There are various problems with the wake up, and sleep and wake up things, magic methods. Serialized and unserialized gives you a way of controlling exactly how your class is going to be serialized, and when it unserializes, how it's going to unserialize, instead of relying on some of the weird side effects that you end up with in the current mechanism. It's a new null coalescing assignment operator coming. So these two are equivalent. Weak references. PHP is reference counted, which means when a variable goes out of scope, there are no more references to that particular piece of memory. It gets freed in the sense that it's available for reuse within PHP. If you have something like a cache system or anything where you want to avoid stopping something from being collected or being reference counted, if you have a weak reference, it doesn't count as a reference. So let's say A equals something that comes back from your database, for example, and you want to cache it. And you say B equals a reference to this, so now you have a reference count of 2. Then you might also have a cache reference to it. Now, if both A and B go out of scope, then this thing should be deleted, freed. But if the cache is still referencing it, the cache will stop it from returning the memory to the system. The cache should then be rewritten to get a weak reference instead. Then it doesn't count. So it's only the two main references that count. And once the two main references go away, it's reference counted and it's freed. And the weak reference dies. Another cool new feature is opcache preloading. It basically loads the user space code at startup, and then any code you have, any classes, any functions, it's as if they were internal for the rest of the life of that PHP instance. That makes it harder to change that code, obviously, because if you need to make changes, deploy a new version, then you can't just have PHP statted and recompile it because it's only looking at this stuff on startup. Or you'd have to do some more complicated things to force a recompile. It's inspired by Java's hotspot VM, and it works like this. So if, say, you have code that just has a class A that echoes out A in the constructor, you probably have an autoloader, and when you do a new A, the autoloader triggers, loads in that PHP file, a.php, and the class is run, constructor runs, we get A. In the preloaded world, if in your INI you have opcache.preload pointed to a script, in this case preload.php, in that PHP script, all you have to do is opcache compile file, whatever you want to preload, by whatever logic you want. In my case, I wrote a little preload function that I can pass the file names to that I want to preload. and I opcache compile file those file names. So in this case, when I run that same script.php, this script here, with the autoloader, you can see that when I run it, it doesn't say that the autoloader was triggered. It just outputs A. Because on startup, it preloads A, and that class is registered. This might seem like a lot of stuff that doesn't necessarily give you a whole lot of benefit. It helps you a little bit because even though opcache compiles and caches the opcodes, there still is a little bit more work to do to bring those opcodes into scope and to create the class in this particular request. For example, you can have 5 classes all with the same name, right, in different PHP files. And depending on whatever context you're loading one file over another, you pick the right class out of opcache and create that for that request. In the preloaded world, you can only have one class with that name. You can't preload 2 classes with the same name. That just wouldn't work. You would get a redefinition error. But it also kind of illustrates that there is a little bit extra work involved if you don't preload something. So it is slightly faster. But where it really becomes interesting is when combined with FFI. Foreign function interface lets you create this FFI object directly from an underlying C library. In this case, this example is really simple. This is just loading in libc and defining, this is basically, think of this as a header file, right? So this is the header file you're loading in that just has the prototype for the printf function. And we're telling it, grab this from libc.so6. Now, off of this FFI object you created, you can now call anything that were defined, any prototypes that were in that header file, you now have access to directly. And you can call directly into the C printf file. Completely useless because PHP already has a printf function that does exactly that, basically. To test it out, I went and grabbed a library called gif-enc off of GitHub. It's a very simple little library. The header file looked like this. The top 2 lines are something I added. You can ignore those, but this is exactly the header files that come with the library, the header file. And it just defines 3 functions. NewGIF, GE NewGIF, GE add frame, and close GIF, right? So this is a little library that creates animated GIFs. It has a somewhat complicated structure for the GIF header, number of frames, color depth, things like that. To load that in, because I added these 2, I set a scope, and I told it which shared library this is in. That's the only 2 things I added to the header file. Otherwise, I just pasted it directly. And I can just load that header file now. And it does everything, and it compiles the code and creates this FFI object. And now I can just play with the FFI object. You still need to know a little bit of C. You need to understand, for example, that this color argument to NewGIF, the 4th argument to NewGIF, if we look at it here, you can see you get a file name, a width, and a height. These are just long, so that's easy enough. But this one here, a uint8 pointer. Uh-oh, what is that, right? If you're in the PHP world, now you're looking at C pointers. You kind of have to know what that means, that this is actually an array of uint8, unsigned integers that you're passing in. So in this space, you have to create this array. And you can say FFI new uint8, and I want 12 of them. Because these are the colors that I'm passing in. And I pass in RGB values for these colors. Then I can call the function. For these, the simple longs, again, we look at the thing, we look at these, go, no, what did I do? Wrong key. You look at these, and you have to know enough C to know that this is just a PHP long will do here. A PHP long will do here. Char pointer, that's just a string. You just pass a string in this case. And again, integer, it's fine to just pass a PHP integer in here. But this one you have to create separately, right? Create that separately, do a bit of loops, add a frame, different colors every time through, close the GIF, and the result is that, which is kind of cool. But preloading plus FFI is super interesting because this step is deadly slow, the FFI load. You do not want to do this on a per request basis. But if you preload this thing, on server startup, all your FFI blocks are going to get compiled and added directly in to PHP as if they were an extension. I can see a whole bunch of our very thin extensions that just wrap C libraries. I can see these being converted to preloaded FFIs that you can just Composer install directly because they're really just PHP scripts. So they can be managed through Composer. And also, all the data marshalling, like all this other stuff is just PHP code, right? The amount of C that's in here is creating that header file, and then a little bit of creating the types maybe that you need a C developer for. All this other stuff, people who only know PHP can happily maintain the other parts of the extension. There's only so much that's actually needed for the C part, right? And you need a C developer to get the base right, but then from then on, any little change to that extension can be done in PHP, managed through Composer. It'll increase or broaden the users, the amount of users that can help maintain extensions. And I think it can kind of change the world for us. We'll see. All right, I know I'm pretty much out of time, but one last little rant. So these 25 years also included having a son 17 years ago, me hacking on some PHP stuff, getting on a ThinkPad. Macs were cool back then, so I had a sticker. I never really converted to the whole Mac thing. But yeah, little Carl, being like 3 days old at that point, I think, 2 days old maybe. A little bit later. Anyone in here remember? Linux Tag, Karlsruhe. Yes, so Carl would run around. He was really, really good at finding the on-off switch on anything. He would run from booth to booth at this big Linux Tags conference, and he would find the off switch and turn off these servers, which didn't, I mean, but he was a cute kid, and he had his PHP shirt on, so they couldn't get too upset at him, but there were a few that were really grumbling, because he would circle back and do it again and again. Now, he's 17, he's driving, playing video games in the car, right? It's a completely different world that we live in now, and he has hair down to his elbows. Yeah, very, very different, and it's making me feel rather old when my son comes and picks me up. Also, over these 25 years, I used to go to Australia every year. We had some great hacker gatherings. This is Andrew Tridgell, famous for rsync and many other things. Linus Torvalds, a bunch of other Oz hackers in here. You can see this was before LCD panels or anything, right? This is old school. Some other highlights for the 25 years. This is me in India at a conference. I don't have a suit like that. These conference organizers thought that, well, their speakers are so important, they should be wearing suits, so they photoshopped me into a suit. And there were these huge posters all over the town of me in this suit looking very important, I guess. And I saw that and go, what the hell? This was another highlight. This was in Sri Lanka. Anyone know who this might be sitting here? You're cheating, but yes, Arthur C. Clarke. One of sort of, oh, you can't see that. Okay, you have good eyes. Yes, Arthur C. Clarke lived in Sri Lanka for years and years and years. He came to a PHP conference and sat right in the front row, asked questions, completely engaged, and it was super cool to teach PHP to Arthur C. Clarke. Although, the really cool thing about this particular conference was that this was in 2005. In December 2004, there was the huge Indian Ocean earthquake. I don't know if you remember, but there was a massive tsunami after that that slammed into Sri Lanka. a lot of people died. Out of that came something called Sahana. And the Sahana project is a disaster relief project. And I talked to the folks there when I was there and talked through some of the things that they could do with PHP and Sahana. And this is one of the things that makes me still contribute to PHP, makes me still feel like it's worthwhile even doing some of the things. I mean, I get slammed with flames and blog posts online about all the bad decisions I've made over the years. But then I go to Sri Lanka and I see something like this. Kid at the university and also a guy working for the government there got together and built a disaster relief in a box management type system, where basically if relief comes in, plane full of diapers comes in, someone on the ground will say, we have diapers, they're over in hangar number 3, whatever. Same for whatever else comes in. So you can keep track of aid coming into the country. You can also, there's also a people finder, so this is a very simple front end for the people finder. There's also a mobile app now where the rescue workers ask the person their name, take them to shelter number 3, and they enter that into the mobile app, and then you're online, you check, where's my grandmother? You put the name of your grandmother in, and it'll tell you, yes, she's been found, she's over there, right? And there are 7, 8, 9 different modules like that. And the value is that this can be spun up in 3 minutes, right? This is just a package that you spin up super, super quickly, and it has been used now in 50 plus disasters around the world. Knowing that PHP has literally probably saved someone's life makes all that online grief completely irrelevant. This is a tool. PHP is not important. What you do with it is important. If you save someone's life with something you've built, that's awesome. Arguing about the color of the hammer used to build that thing is just moronic. And all these flames about the technologies and stuff, we can't lose track of what we're doing here, why we're programming. We're programming to solve a problem. And hopefully, it's a problem that actually matters, right? It's a very nice quote from the National Secretary of Defense of the Philippines who said that, right? Directly targeted as Sahana, because he saw what Sahana did for a big disaster in the Philippines. So it was a mudslide thing back then. So work on things that matter to you, please. I see a lot of people that have left. There are a lot of people I don't see in this room and in other conference rooms that I go to that were there 10 years ago. But now they're middle managers. They're not programming anymore. They burned out. They changed jobs. And sometimes that's just sort of the progression, and it makes sense for them, and they're good managers. There are also a lot of really crappy middle managers out there that were great programmers, and they become crappy managers because they don't feel like they can keep up. It's too much work to keep up with how fast technology is moving, which is kind of code for that they've lost interest. They're not motivated enough to actually sit and read about things in the evenings. They have families now, and it takes more time, and I understand that. I have a family. But there's still this drive, there's this passion and motivation that makes me continue. If you don't have that, you will burn out, and especially the younger folks in the room. You love programming, but will you still be programming when you're 50, 60, 70? Maybe you don't want to, and that's fine, perfectly fine. But if you want to, if you love what you're doing, really look at what you're actually doing. And don't worry that much about the tool. If you switch tools, fine. It's what you build with it that's important. I'm sure there are all kinds of geek arguments about paintbrushes. What's the best paintbrush that painters might have internally? It doesn't matter. What people remember are the actual paintings, right? Who made well, I was going to say Michelangelo, but he's a big PHP guy, right? So, uh, but I mean, who built Mozart's piano? If you're a music geek, you probably know. I mean, maybe you know. But who built the piano isn't as important as the actual music that was created with it, right? And that's what we're doing. We're building things. And things come out of this, I think. I am squarely in the middle of this chart. I can code a little bit. I'm not a very good coder. I'm sort of a mediocre coder. I don't particularly like programming. I built PHP because it was too complicated. The tools I had at the time just weren't up for the actual task, I thought. It took me too long and it was too hard and too tedious. So in order to program less, I spent the next 25 years programming something that would let me program less. So it made no sense. But still, it did allow me to build things along the way that actually affected people's lives. And that still keeps me going. And I'm very, very thankful for the whys. There are a lot of whys that have helped out on the PHP project over the years. People who just love to code. Doesn't really matter what they're coding. They just sort of love the act of coding. They love the journey. They don't really care where they're going. It's kind of like flying, right? I hate flying, but I spend my life flying. I fly a lot because I want to get to somewhere, not because I just like sitting in this smelly little tube with a bunch of people, right? And same in there are lots of dreamers out there that have absolutely no basis in reality to know if they can build some of these dreams, and that you need a little bit of grounding to figure out if this grand idea you have can actually work. All right, that's my rant, and I know I'm over time. Sorry, conference folks. So, slides are there, a couple of links. Thank you.